Have you ever looked at a pile of old batteries lying around in a drawer and thought, guess I'll just have to throw them away? Don't be so quick. With a bit of DIY creativity, those old batteries can be reused or turned into some really cool tools. Some of the batteries are dented and deformed, looking almost impossible to restore. But remember, handle batteries carefully and make sure to recycle them properly if they're truly out of juice. Now I'm going to open it up. If you're curious to see what's inside and how we can possibly bring it back to life. Stay tuned and watch till the end. Now I'm going to pull out the positive terminal, and as I do, the inner core of the battery comes out along with it. Next, I'll move on to the next battery, carefully cutting it open to see if its inside is in better condition or just as damaged as the first one. After opening the battery, I take a small stick and carefully start scraping out all the material inside. The inner core is dry and flaky, breaking apart easily as I dig through it. Bit by bit, I remove the black powdery residue and the compacted layers that have built up over time. Inside, there's a layer of black powder. That's the active core of the battery. It's mostly made of manganese dioxide and carbon, the materials responsible for generating electricity when the battery was still working. Over time, this mixture dries out and loses its power, turning into a brittle, dark residue that shows the battery has truly reached its limit. Next, I'm going to work on the battery core and the outer shell. The inner core still has some residue stuck to it, so I'll clean it thoroughly to remove any remaining powder. To clean both parts, I start with the inner core, wiping it carefully with a dry cloth to remove any leftover black powder or moisture. Once it's clean and smooth, I move on to the outer shell. I peel off the printed label and any plastic wrapping on the surface, revealing the bare metal underneath. This will make it easier to reuse or repurpose later in the project. As for the black powder, I'm going to heat it up to dry it out completely. This will remove any remaining moisture and make the material easier to handle later. I'll do it slowly and carefully to avoid burning it. Just enough heat to let the powder regain a dry, fine texture. Any remaining clumps I'll break down with a small metal punch. Gently tapping and crushing them until powder is uniformly fine. I do this over a piece of paper to catch the dust, and I wear a mask and safety goggles so nothing gets in my eyes or lungs. Once all the preparation is done, I'm ready to dive into the main part of the project. I'm going to use some baking soda and super glue to secure everything in place. The baking soda helps the glue set quickly and adds a bit of bulk. I pour a small amount of baking soda into the empty battery shell, making sure it spreads evenly along the bottom and sides. Next, I carefully add a few drops of super glue on top of the baking soda, letting it seep in and bind the powder to the shell. Once the shell is nearly filled with baking soda, I place the clean battery core on top pressing it gently so it sits securely. This ensures that the core stays in position while the glue sets and everything bonds together firmly. Next, I'm going to grind down the remaining tip of battery core. Using a small file or sandpaper, I carefully smooth it out, removing any sharp edges or uneven parts. And just like that, I've finished creating the tip of the soldering tool. It's now smooth, secure, and ready to use for the next DIY tasks. Next, I'll move on to preparing the wiring. This involves selecting the right type of wire, cutting it to length, and stripping the ends so it can connect securely to the battery shell and the soldering tip. I use some strong adhesive tape to secure the wire in place, wrapping it neatly around the connection points. This keeps the wire from moving or coming loose during use, ensuring a stable and safe connection between the battery shell . At the other end, I connect the wire to an alligator clip. This allows me to easily attach the DIY soldering tool to a power source while keeping connection secure and flexible for different tasks. Next, I prepare an additional wire with alligator clips on both ends. One clip will attach securely to the power source, while the other will clamp onto the object I want to solder. For the power source, I'll be using a standard motorcycle battery. It's a 12V lead-acid battery, powerful enough to heat up the soldering tip and stable for small electronics work. This type of battery is easy to find, rechargeable, and delivers consistent current, which makes it perfect for our DIY soldering project. The tip gets glowing hot quickly, allowing it to melt solder and make precise connections. Now I'm going to test it by soldering two razor blades together. After soldering the two razor blades together, the joint feels surprisingly strong. Even when applying pressure or flexing slightly, the blades stay firmly connected without any signs of separation. The solder has bonded well to the thin metal surfaces, creating a solid bridge between them. Now I'm going to fix a small hole in the plastic. I position the soldering tip near the damage area and carefully melt the surrounding plastic, filling the hole and smoothing it out. Next, I place a small piece of steel mesh underneath the work area. This acts as a protective layer, preventing direct contact with the surface below and distributing the heat more even. I use a soldering tool to secure the metal mesh onto the plastic, carefully applying heat along the edges. I melt the plastic just enough for it to grip the mesh firmly. Once cooled, the mesh is firmly embedded, providing extra strength and stability to the repaired area. Next, I take the black battery powder I prepared earlier and use it to fill in the missing sections of plastic. I place some tape underneath the area as a protective layer. This prevents the powder and any melted plastic from spilling onto the surface below. I combine the battery powder with a few drops of super glue, mixing them into a thick paste. Then I press this mixture into the gaps and missing sections of plastic, filling them completely. The glue binds the powder firmly, creating a hard, solid filler that restores the shape and strength of the damaged area. After filling the gaps, I let the glue dry completely. This ensures that the powder and glue mixture hardens into a solid, stable layer, making the repaired plastic strong and ready for the next steps. Once dry, the repaired area is hard and firm to the touch. The black powder blended with the glue forms a solid, slightly rough surface that fills the missing sections completely. It holds its shape well, providing stability and strength, and is now ready for any further finishing or smoothing if needed. If you want a smoother, more polished finish, you can use sandpaper to gently sand the surface. This evens out any rough spots, blends the repair with the surrounding plastic, and gives a cleaner, more professional look. The battery serves as the power source for the DIY soldering tool. It provides the electrical current needed to heat the tip, allowing it to melt solder or plastic. Without the battery, the tool wouldn't generate the necessary heat, so the soldering or repair process wouldn't be possible. Essentially, the battery converts stored chemical energy into electrical energy, which then produces heat at the tip for all the DIY tasks. And that's it. With a few simple materials and some careful steps, we've turned old batteries and scraps into a fully functional DIY soldering tool. Not only does this project give new life to otherwise discarded items, but it also shows how creative thinking and basic materials can solve practical problems. Remember to always handle batteries and hot tools safely, and you'll have a handy, cost-effective tool ready for all your small repair and DIY projects.